I'm Roger Webb and welcome to this Carveco Maker Plus tutorial. So in this tutorial today we are going to be making the mounting plates or brackets for these high-powered NEMA 24 stepper motors, which is a fairly simple process and it can be very easily done in Carveco. So the first thing we need to do is measure how big an area we're working with. So it's 60 millimeters by 60 millimeters square. And for a project like this where we need to, I'm going to need to make a pocket to fit, you see this motor boss here, okay? I'm going to make a pocket for that and then spot these holes for the housing, and that's all I need to do. And I've found through experience that using the center as the 0 point is probably best for this sort of situation, because if you're wondering what this is here, this is the reason I'm doing this pocket in, because my hole saw is blunt. It wouldn't cut through it. So what I need to do is cut this pocket out, spot 4 holes. But if you notice, this is for the X, so this is only just slightly off-centered. But for the Z and the Y axes, they're quite a bit off-centered. There's more of a measured amount off-centered. There's about 10 millimeters difference. So making the center of the drive shaft then, the 0 point, that is best in this case, because I shall be setting the 0 on the machine using that center hole, okay, and running the code to first of all cut the pocket out, and then to do the spot the 4 drilling holes, and then rotating this around and re-zeroing the start of the program in this case, and I'm going to do 3 like that. So the first job is to set the material up and the 0 location of the job. So this is also a real-world application of Carveco Maker Plus. Okay, so to start a new model or new job in Carveco Maker Plus, you just come up here and then we need to select the measurements we require. So I need the piece of material that I'm going to be, or the area that I'm going to be working in, is 60 millimeters by 60 millimeters, and that's the actual area of the end of the NEMA 24 stepper motor. And I need to register off the hole in the middle. Okay, so we're going to make the hole in the middle the 0 or the G54 is the technical term for it in G code, and we're going to OK that. So as this screen is opened and the color of this is yellow, that's indicating to me that this is the 3D screen. Well, we're actually doing a 2.5D operation, and I find it easier to draw in the 2-dimensional. So you hit the 2-dimensional tab up here and you can see it changes to virtually a black and white screen. So what we need to do is place our pocket or cut out the hole in the center. So we choose a circle drawing tool, and you notice the cursor here will pick up the center of the material. So there it is there, and just draw it out, release it, and I did that with the left mouse key. And you can also check it up here that the actual center of that circle is in the X0, Y0, which is in the center of that material. If you remember just now, we made the datum point, or the 0 point, the middle of the work. And the diameter is, oh, let me just check the diameter of that. Got a vernier here, checking that, that's 38 millimeters. So we can, and we're in diameter mode there, so 38.0 millimeters, and we can press create, and there it is, done. And we can come out of this now by pressing that. So to deselect anything, you can come over here on the gray area and left click. So now nothing is selected. Now if you require a grid or some measuring devices here to assist you, you can come up to the view and then come down here, and you can either show grid, in this case it's his dots. You can change this to lines if you require. You can also have show rulers, so you can show rulers. This sometimes help you to you know, position a part, but I just normally like using, so get rid of the grid, I just normally like using the rulers. So what we need to do now is accurately position 4 holes. Okay, the drillings. So what I'm going to do to help me position those is get a square, just come here, anywhere here, and just draw the square like so. Now we can position the square, so we tell it we want a square, not a rectangle. Then I'm going to position it into the middle of the, or centrally position it, so I'm going to go 0.0 in the X and 0.0 in the Y, and then we're going to give it some absolute dimensions, and let me just check the hole centers, 50, so it's 50.0 by, oh, done it for me. See, Carveco does actually preempt what you want to do, and it sort of helps you out. So create, and oh, we can cross out of that, deselect. Now I've only put that there so I can position the drillings very accurately. So I'm going to go circle. Now this should snap to that corner like so, and we can draw it out. This needs to be, now this is telling me I am 25 millimeters in the Y plus and 25 millimeters in the X negative, which is exactly where we need to be. And we need a 4 millimeter hole there, because that's a tap-in size for 5 millimeter thread, roughly 4.0. and we're going to say create. Now it would be a very simple job for me to do another hole there, another hole there, and another hole there. But I'm going to show you a different method, so I'm coming out of that. And with this one selected, I am going to go to the block copy rotate. This brings another dialog box up. So in this case we need a block copy. If we choose this one, it would do a circular pattern, or tend to put it in a circular pattern. I will show you this. I'm going to select this one and I'm going to show you what will happen. This is actually set to what we require, 50mm. Now this one will position the holes up that direction, so we want to change that to a downward direction, 50mm downward direction. So you can alter that just by left clicking that, and now you watch what happens. Two columns, two rows. Now you watch what happens when I do this. It'll look weird. Okay, see, it's offset. Okay, because it's done 50mm between the edge of that hole, the inner edge of that hole, and the inner edge of that hole. So that's why it's positioned it further out that way. So we will delete that. It's easy to delete anything. You just come up here and undo. So we'll choose this one. That's set correctly, and apply. And it will put them exactly where you want it. Now the square here is really just a visual effect, just to give you a visual of, oh yes, okay, it is in the right position. It's an assistance, I suppose, lining that I prefer to use. It doesn't have any other purpose than to do that. But as you can see, Carveco really doesn't need it. All it needs is the correct figures, the correct positioning, and the correct, shall we say, geometry, and it will do it all. And obviously you need the correct distance, so it's plus y minus x 25 25 to position, to know that that circle is positioned in the right place. Okay, so we can come out of that one, deselect. Now I'm going to reselect the square and delete it. Now to delete it, you just press delete on your keyboard. So now it comes to toolpaths. We'll jump now to the 3D screen, so we can actually move this around in 3D space. So I go there, and let's choose this one. Okay, so now we can see what's going on in 3D space. So the first item we're going to deal with is the pocket or cutout. Actually, there's two ways we can do it, but in this particular case we're just going to cut this one out. Now to get at the toolpaths, you can either go here or you can go here, and we're going to be doing a 2D toolpath. Now I can either do an area clearance. If it was a solid piece of material, you know, a solid block, I would go and use this. It's a piece of 6mm aluminium plate, so we're going to go profile. In the profiling tool you have the opportunity to go outside, along, or inside, and in our case we want to go inside. And the selected vector, better select the vector. Selected vector, these, in this particular case we don't want to worry too much about this. If it was a precision part that I was going to put a bearing in or something like that, where I want it sort of plus or minus half a thou, then I would use a final pass thickness. So start depth will be 0. I always put 0 at the top of the material. Final depth. Now I want to cut this all the way through and have a nice clean cut. So I'm going to say 7 millimeters. Yeah, 7 millimeters. 7.0 millimeters. Even though the material is 6 millimeters, so that means I'm going to have a sort of a clearance cut, a millimeter all the way through. It'll clean it up nicely. Now, the tool I'm going to be using is a 6 millimeter end mill. I'm going to select that. Now we'll go in and choose the settings for our particular application. We're not worried about a step over because we're going to be doing a profile cut, so this really isn't going to make any difference to us. Step down. Now my little mill would probably cut that depth, but not at that speed. So what we're going to do is we're going to go down 1 millimeter at a time. So we're going to say here 1 millimeter depth of cut. Now this is probably a little bit, it'd be okay if I was cutting MDF or any type of wood. 20 millimeters a second would be absolutely fine. But in our case we're going to go, I think, 6 millimeters per second. Plunge rate, actually plunge rate would be okay, we'll go 5. RPM is, let me see, 5,000. Tool number doesn't matter. I haven't got a tool changer, so that really doesn't matter to me. Climb milling, yes. Add not lead in moves. We want ramp moves, yes. Zigzag, yes. 10 millimeter, 3 millimeter. These are all set. It's what I normally use. Start 1 millimeter. Yep, that's okay. Add bridges. Now, I've no real need for me to have a bridge, but we will. We'll put one in just so I can show you how the bridges work. Now you can select any number you want. Really, it can be 3, 4. We'll say 4. Length, say 6 millimeter. Thickness 1 millimeter. 3D bridge, yeah. Add the bridge at start point, yes. So let's have a look. Yeah, okay, see, this is that's where it's going to start, where that green spot is there. That's where the cut's going to start. So it's going to, the tool is going to come from hovering over the material here, and it's going to come over here, then ramp down in and go around that direction. That's what that little green spot denotes there. A little bit too many, I think, bridges. So we're going to say, oh, well, we'll remove all of them first, and then we'll go in here and say, well, we just want one. Add, so you can add it. And you know, if you can put this bridge anywhere here that you want to. So we'll stick with one bridge, and we'll go further down through the conversational here. Cut sequence. This is for holes, really. Multiple holes. Save Z 5 millimeter. Okay, so we'll set the material up now, and we're going to say this is 6 millimeters, and we're going to OK that. and I was jumped to face on now so we can see what it is. So we're going to say this is cut 1, and we're going to say calculate now. And there it is. And we're going to come out of that. And so there's a tool path where it spirals down. And you know, you can always simulate. So we're going to simulate that. Standard simulation, yep, everything's okay there, simulate. And this is what it's going to look like. So we'll simulate. And this is exactly what it's going to do. Incidentally, to get the geometry back, we just come here and press that. And deselect that. Now select these. So to select all of these, so you just select the one, press shift, hold shift down, and select these so they change to a purpley color. So they're all selected now, and come back up here to tool paths, and it is a two-dimensional or 2D tool path, and it's a drilling. So it's the selected vectors we want to machine. Start depth 0, finish depth 6. Actually, we don't want to go that far. We want to go 3, because what I'm going to do is I'm just going to spot these drills and then drill them out by hand. Plunging clearance 1 millimeter. Okay. Now the tool we're going to use is a center drill or a spot drill, and it is we'll use it as a ball mill. It doesn't matter. You know, there are drills down here, but you know, as long as you know what you're doing. It's a 2 millimeter. We're just going to use the 2 millimeter end. In actual fact, probably won't use a ball mill. Let's do it properly. We'll use a 3 millimeter end mill, and I'm going to make a 2 millimeter end mill. I'll show you how to make a tool in Carveco. So what we're going to do is we're going to copy it, and we'll leave it on the highlighted one there, the bottom one, and we're going to edit this, and we're going to say, well, it's a 2 millimeter. We'll still call it a slot drill. In actual fact, we'll still call it a slot drill. The tool number really doesn't matter. Millimeters per second. This is just the, you know, what dimensions it is going to be in. The feeding speeds in millimeters per second, which is fine. And we're going to change this to 2 millimeter diameter. And this is what changes in the settings for the tool when you do choose it. Step down 2.2. I'm just going to go 1.0. Step over size, we can leave that. We can leave that. These will all change. You know, when you choose a tool to do a certain job in Carveco, when you choose a tool, you change these at that time. These are just average, normal type settings. So I'm going to OK that, and I'm going to choose that. So now it comes into conversational, and we're going to say, okay, so we know that's correct. 2mm is the correct tool. Feed rate, at this point it doesn't matter because we're not going to feed it anywhere, so I'm just going to put that just 1. Plunge rate, now this is the one that counts. I'm going to say 2 millimeters per second, which is fine. RPM is going to be 5,000. There again, the tool number doesn't really matter, but you can change it to anything you want. You can call it, in this case we'll call it tool number 2. Doesn't really matter. Drill central. We don't need to change anything there. Use peck drilling, yes. Okay, that's fine. Sequence, we're going to leave that on auto. Carveco is quite capable of choosing which one to comb first, and you know, it'll do it the most direct manner, most efficient way. Material safe, 5mm, that's okay as well. Material thickness is, that's okay. So we're going to say here, this is op 2, and it's 2mm. To drill. Okay, and we will calculate now. Okay, so that's calculated, and we can run that as well. Now if you open the simulation up here, you can go down here and change the material. This is set for aluminium at the moment as default. So what I'm going to do is just to show you how to change. Bronze is quite nice, and we're going to apply, and there's bronze. Oh. So you can actually turn that off for the simulation, and if you want to move it around, you can. I'm hovering over the material, and I'm holding down the left and right mouse key, and I can move that around. And if you want to move it, sort of orbit this in 3D space, you just hold the scroll key down, and you can move it around bodily in 3D space and have a look around it. You can also zoom in. If you just scroll, you can zoom in and zoom out as well. So that's how to change the material appearance, color. I personally like the bronze, or the gold is nice. So the next thing to do is export the toolpaths. Now that's very easily done. Press on toolpaths up here, which brings this dialog box up, and you just press on the floppy disk emblem. A lot of you won't know what a floppy disk is, but that's a floppy disk. That's how we used to save things. In the J, yeah, that's correct. So you can move these around actually. So you can move, if you choose this one, they'll all go over. But if you sort of select one here and press that, it will save just the one. So cut one, and it's a 6mm. Okay, so I can now just say, now there's an important thing. If you are using an SMC controller, you will need to save in G-code millimeter tap or Mach 3 millimeter tap, and you won't have any problems. Now, I do understand people are having problems with Fusion 360 with the free program because it doesn't have the ability to save a tap G-code. You have to purchase the ordinary license for Fusion 360 to have the ability to save in a tap G-code file, unfortunately. And that's why we're, sort of Carveco wins, because all the Carveco programs have all of the possible outputs of G-code, and it is, like Carveco Maker is very, very reasonably priced. In fact, it's the best priced program on the market for hobbyists, as is this one, which is Carveco Maker Plus. If you want to create 3D reliefs, this one will do it for you. And of course then there's Carveco, the main program, which is sort of really, really professional and really, really good. But this particular program, Carveco Maker Plus, is fairly equivalent to Vectric Aspire at half the cost. So there you go. Oh, and incidentally, below this video in the video description area, you will find a 5% discount code for any of the Carveco programs. So we will save this one in the appropriate, and I always use this one whether I'm using Mach 3 or not. This is a general purpose tap file which works everywhere on everything. Save. And it's as quick as that. Take that one back over, the drill in. So let's alter this to cut 2, drill and save, and the job's done. So there we go. I hope you've enjoyed this very simple Carveco tutorial using Carveco Maker Plus for making tool paths for a milling machine or a milling operation of a standard type of part. Of course, this program will do much complex parts than this, as in the future I will show you. So please like and subscribe, and if you like the videos on my channel and you'd like to support the channel, down in the video description area you will find a link to my Patron page, which would help me out a great deal. So thank you for joining me, and it's bye for now.